Okay, ready to get started on the first one. Again, my goal, set up two equations again. All right, so I have a 10% solution I want to mix with a 60% solution to make a 30% solution of 50 milliliters. I'm going to make this easy on you. Here we go. Let's make beakers. This plus this has to give me that solution. What do you know about the first solution? 10%. So I'm just going to put 10% in here. Do I know how much I need? No. That's what I'm trying to find. How much of that 10% solution do I need? What do you know the next one? 60%. Do I know how much I need? There's my second variable. Y, right? I mix them together. What do I need at the end when I mix them together? I need a 30% solution, but I need how much? 50 milliliters. How much of each solution will I need? Well, let's set up the first equation. The amount of 10% plus the amount of 60% has to give me how much? 50. X plus Y equals 50. All right, X plus Y, I need 50 milliliters total. Where's the second equation come from? Here comes your percents now. Here comes your percents. I need 10% of some solution, right? And you guys know I don't want to plug 10% in, I want to plug 0.1, so I'm going to put 0.1 times X plus, how much of the Y do I need? 60%, so 0.6Y equals, and then over here, I already know how much solution I need, which is 50 milliliters times its percentage, which is 0.30 or 0.3, whatever you prefer. There are my two equations. The 10% plus the 60%, I need 50 milliliters total, and then I plug with the percents in them times how much I have. All right, I would probably clean this up right now. 50 times 0.3, can we do that right now? 50 times 0.3. And that'll end up being 15. All right, so I'm just going to, you can write it over if you want. Or if you do, hey, just make sure, make a note of yourself when you go and look at this for Tuesday's quiz, or Monday's quiz, excuse me, where that came from. That's 50 times 0.3. All right. Did we solve these all the last two class days we've been together? System of equations. We can either do substitution, solve for one of the variables, or we can do elimination. We did a bunch of elimination. Seems like you guys picked up on that very well and remembered it. So what do you want to multiply by? I have to eliminate one of the variables. There's a lot of things we could do. Negative 0.1, fine. Let's multiply that top one by negative 0.1. Distribute the negative 0.1 all the way through. So I have negative 0.1x. Next, minus 0.1y equals, keep distributing, 50 times negative 0.1. Negative 5. There it is. What happens with your x's? They're gone. That was our goal. 0.6 minus 0.1. 0.5y equals 10. And y will be equal to, go to the calcs, 10 divided by 0.5, 20. So what's that telling me? How much of the 60% solution do I need? 20 milliliters, yep. I need 20 milliliters of the 60% solution. What about the 10%? What are you going to suggest I do? plug it into one of the originals. Which original do you think it's probably the easiest? X plus y equals 50, right? So let's go back. X plus y equals 50. You already know y is 20. And if you can do this in your head, I wouldn't expect you to show me the work if you can already tell me I got 20 and I need 50 total, what it's going to be, but I'm okay with that, given you're at this level of math now. How much of the 10% are they going to need? They're going to need 30 milliliters of 10%, right? Yeah, 10%. Make sure you get little labels on there for me too. Or if you want, you can also just put in, what was it, 20 and 30. You can also just write in 20 milliliters, 30 milliliters up here too. That's fine with me either way. I just have to know what goes with what. Anything you want to ask here? A little mixture before we start going peanuts and cashews? Sorry, tea. Peanuts and cashews, I think, are in the class work. All right, here we go. Tea, same thinking here. $6 a pound tea, $8 a pound tea. I need a mixture to get 144 pounds of a tea worth $7.50 a pound. So instead of percent, I got money now. Okay, I got money. That's it. All right, instead of the percents, I have money. Set up. Here you go. Here's my bags. The old peanuts or tea. Tell me I'm not going crazy. We have peanuts coming up. Probably not. Yeah, we have peanuts coming up tomorrow. All right. All right, here you go. What you go in the first one? Tea worth $6 a pound. So instead of percents, I know it's $6 a pound. Do I know how much tea I have at $6 a pound? Nope. So X. What's in the other one? $8 a pound. I do not know how much I have in there. But I want to make a mixture for what? $7.50 a pound, and I need 144 pounds. All right. Give me one equation. I'm going to turn it over to you guys now. Here we go. Give me one equation. I have no idea. Not good. 5, one equation. Perfect. 7. Okay. All I want is one equation. Yep. T for $6 a pound plus $8 a pound. I should have 144 pounds. All right. Perfect. That gives me the pounds. Now involve the money for me. Involve the money for the second equation, number 3. 6x. Yep. Per pound. Because I have 144 pounds, right? And then what's that? You guys finding 1,080? 1,080? Okay, so I'll replace that. Just write a little note where that came from, that 1,080. That's 144 times 750. All right, it's up to you. What do you want to do to solve? Let's go. 8. What do you want to do to solve? -6. You all right back there, Hannah? You all right back there? Okay. We did the canoe problem. We did the canoe problem last. Oh, sorry. But we did the canoe problem last time. You didn't need to bring your life jacket in today. All right. All right. Second semester, roasters on fire. All right. Second semester here. I kid, Hannah. I kid. -6 times 144. Anybody? What do you got, Stud? All right. What's left? Not off the hook that easy, everybody. What's left? Here we go. 14. What happens to the x's? See you later. What? 8y minus 6y. Nice. Let's finish this. A lot of $8 a pound tea, huh? 108 pounds. LBs, as we like to say on the street. All right. Did you even pick that up, Matt? LBs? Pounds? Okay, good talk. What about the $6 a pound? Substitute back in. You know you need 144 pounds total, right? So x plus your 108 equals 144. So I'm going to need how many pounds for that one? Number one, how many pounds? $36. Not money, sorry. So 36 pounds of the, what is that, $6 per pound? You already lost, sorry. You already lost it. I already lost it. All good. Mixture problems. No issues before we go motion problems. We're on a plane, little wind speed. All right, here we go. Whew, how about this? Little small plane, flies with the wind. It can travel in 3 hours. When the same plane flies in the opposite direction against the wind, it's going to take 5 hours to fly the same distance. Find the plane speed and the air speed, or the wind speed. Ho, ho, ho! Ready for this one? You're still setting up two equations here. I'm not changing that. All right? Up until we pass the quiz on Monday, I'm not getting past two equations. All right? So first of all, what are the two things I'm asking you to find? Plane speed, all right? So we'll just call that P for plane speed, or velocity if you'd like to be fancy. And what's the other thing I'm looking for? Wind speed, speed of the wind. All right, let's talk. The first one, this 450 miles in 3 hours, what's happening? The plane is flying with the wind. All right, wind at the back. Here we go. I'm done. Embarrassing myself. All right. So you get the plane speed and the wind speed together. Everyone agrees. The plane and the wind speed together. We're all good? So what I'm looking for in the first equation, the plane speed plus the wind speed going together, what's the distance I'm traveling? 450. But I'm doing it in 3 hours. Everything times 3 over here. Okay? Because 3 hours times the plane speed plus 3 hours times the wind speed gives me a distance of 450. So all of it, or you could put 3p plus 3w. I'm just showing you a shortcut right now, Carter. Watch this. Okay? If you want to put 3p plus 3w equals 450, that's fine. Think about the next one then. Now I'm going against the wind. Whoa, buddy! Great job. Get out of my face, not Bergie. Okay, you need more than that. All right. Sorry, you're right. My bad.
Oh, no, I'm not
My
doing
bad.
it. Now you're going to pull back or something. I know you're going to.
You're good, Matt, because I was, and then I was going to go for a third time until you stopped. Yeah, you're good. You're good. Way to go, bud. Way to go. Yes, the next one, when you go in the opposite direction, now I don't have it with the wind. I'm going against the wind. Still traveling how far? 450. But now it's taking me 5 hours to do. Now you have an option. Can you distribute the 3 to get 3p plus 3w and the 5 to get 5p minus 5w and solve it like a system like that? Yes, you can. I'm going to make things a little easier, though, on you. Okay? What's happening between the 3 and this whole quantity of p plus w? Multiplication. So if you wanted to get rid of the 3 right now, you could. How? What's happening between the p plus w and the 3? Multiplication. So if I wanted to get rid of the 3 right now without distributing, I can divide by 3. So really, I could change this into p plus w equals 450 divided by 3, which is 150. And what could I do over here as well into this second equation? Divide by 5. So I would have p minus w equal to 90. Why do I like this better than trying to, anybody? Why do I like these two better than these two I'm writing up here if I distribute it? Why are these two equations better than if I distribute it? Boom! See you later. W's are gone. Over here, you're like, oh, cripe! I got to multiply that by a 5, that by a 3, a negative. People start complaining, and I get furious. All right, because I don't want to hear it. All right? Does everyone see that this is a little bit more advantageous? No. Get off. Yep. To your advantage, yes. So yes, the W's cross each other out. What am I left with? 2p equals 240. So my plane speed, 120 miles per hour. It's a small plane. Did you read the problem? That's your plane speed. P was for plane speed, remember. 120 miles an hour. Both of them. Yeah. No. What's different is how long it takes them to go 450. Like, here you go. Ready? I'll show you at the end, Matt. So the plane speed, 120 miles per hour. How are you going to find the wind speed? Plug it back in. Okay? You can plug it back in anywhere here. You probably would prefer to plug it into either one of these, right? So 120 for my plane speed. My wind speed would be what if they have to add up to 150? 30 miles per hour. So Matt, going back to your question, both scenarios are going the same speed. First scenario, though, it's going 120 with a 30 mile per hour wind pushing them. The other one, it's going against them. Okay? Questions on the speed here? Okay, one more. You're going to take over this one. Still a plane question here. Oh, rowing. Here we go. With the current, you can row 24 miles. Do I have any rowers in here? Any rowers? No?
I worked on it.
What was that? That looked like you were having a seizure. That looked like you were having a seizure right there. You just lost total control of your arms. All right?
I do have another one.
You do, because you're frail. Yep. All right, against the same current, you can only row 2/3 of this distance in 4 hours. Find your rowing speed and the current speed. All right, so here we go. Rowing speed, we'll go R. Current speed, we'll go C. First equation. Here you go. Focus in. First equation. Here we go. Who's got 11? Okay, ready? With the current, you can go 24 miles in 3 hours with the current. So what do I want to do with these if I'm going with the current? Okay, so R plus C, what's your distance, Carter? 24 miles, and what are you doing it in? So 3 hours. I can do all that in 3 hours. There is a little catch here at the end. Okay, against the same current, you can row only 2/3 of this distance. So it's not equal to 24 anymore. Here you go, 15. Who's got 15? Hello, Caroline, how are you? So against the current, I want to go rowing minus it, but it's not going to be equal to 24 now. It's 2/3 that distance. 2/3 times 2/3, yep. And how many hours can I do this in? Against the current, it takes me 4. So I want to multiply that by 4. Everyone look at the setup. We okay? All right, here we go. I would just maybe clean 24 times 2/3 up. Anybody? 16? Again, I'm just going to make a note. That was 24 times 2/3. Now, again, you want to distribute? Go ahead, Hannah. Hi. Because it took me 4 hours against the current. It took me 3 hours with the current. Right? You okay? Yeah. All right, we're all good. Everyone else all right? What are we missing here back there, ladies? Okay, here's where this is all this is stem. I didn't want to break this out today. All right, but this is where this is all stemming from. You guys have maybe some science classes, past math classes. Rate times time equals distance. Okay, rate times time equals distance. So distance equals your rate, which is both of these times the time. That's where that's coming from. Okay, if you wanted a rate times dirt, as I don't know, anybody ever refer to it as dirt? That's how I remembered it. Dirt. Okay. All right, regardless, I want to get through this here, so the rest of the time is yours. I don't want to solve this. I can divide here about both sides by 3, so it's going to be R plus C equals 8, and then over here it'll be R minus C equals 4. Again, you guys are wondering, I'm dividing both sides by 3, dividing both sides by 4. Uh, 12. Hi, Shannon. How are you? I'm hanging in there. Thanks for asking. What crosses out here? And what's left with the R's? 2R equals 12. So what's your rowing speed? 6 miles per hour. Yep. Six miles per hour rowing, which would mean what is the current speed? The water of your, oh, yes, 2 miles per hour, because it should add up to 8. Yep. Yes. How did I get R plus C, or do I need, what was your question? Yep. Yeah, you can go back to one of these original, yeah, as long as they're divided right. Yep. Anything else? Okay, some of you guys have some stuff to clean up from the previous classwork, but tomorrow is only 5 problems tomorrow, some mixture of motion problems. Okay?
How's your snow day, Mr.